In this video, let's talk about strongly connected components in directed graph. Sometimes there are loops in the directed graph, so you can reach all the vertices on this loop start from any vertex. And for example, here is a loop, here is another loop, and the vertices on the loop belong to strongly connected components. Sometimes loops go side by side and they merged into one strongly connected component. And we can use kosaraju's algorithm to find the strongly connected components in directed graph. Knowing that knowledge is useful when we have websites connected to each other. If you have an outbound link to side B and side B give you a backlink, then your side and the side B became strongly connected, and Google will give the two sides higher rates. And so let's write a program to find strongly connected components in the internet. Before we go to internet and cause alarm during the development, let's first create an intranet and try out our algorithm there. And we can create a HTTP server and serve some interconnected web pages. And we can write a program to generate those HTML page we need. So just put some start page and outbound links, and then we can use that knowledge to create HTML code and write it into a file, into files in a particular directory on your hard disk. So here is what we do. After running that program, this HTML file is created. We can randomly check one of them, like say 1-v0, and it have a page name and URL and links to other pages. That's the content of this HTML. Now we have a list of HTMLs. We can have a web server to serve them, and Python provided a simple HTTP server. So once we run this program, we have a web server listening on the port 8080. So let's go there. As you see, now we get a have you started yet? Serving, okay. Not reachable. Localhost, okay. Let me start from localhost. Okay, and here are a few websites I can go. I can go to localhost 2. As you see, some site is localhost 1, some is localhost 2, and there could other localhost. But I have only one IP address, which is 102.0.0.1. So in order to host multiple sites, there is a small trick to play. So here, if we add a few entries in the auxiliary hosts, we can create a multiple aliases. They both use local IP address as an IP. So that way, we can use one IP address to host multiple websites in order to get a intranet. Now we have that intranet up and running, and we can have the web crawler to crawl it. So here is the start page. We add a start page and we start to crawl. The crawl is called a parallel crawler because we use parallel stream. and it's recursive. You get you parallelly process the URL in the set, and for each URL you pass out all the adjacent links, and you start to crawl them, and because you recursively call itself and you use parallel stream, more and more tasks are added into the fork join framework's threading pool. And so this get URL is not very interesting. You just read the web page's contents, and you figure out all the URLs, and then you return it. The interesting part is after the crawler finish crawling all the reachable web pages, it will generate a digraph, and kosaraju's algorithm gathered the digraph. It create a reverse digraph, and it do a depth first search. Once it get a depth first search, it will gather the reverse post order. Once the reverse digraph is reverse post ordered, the vertexes on the strongly connected components are in adjacent position. So if you loop through the original graph by following the reverse post order, and you mark them, you mark them with the same count, then you find all the strongly connected components. So just by using reverse post, and you topologically sort the reverse digraph so that the vertexes in the strongly connected components are in the adjacent position. Then you can walk through, do the depth first search for the original graph, and mark them. Then you find the strongly connected components. So let's run the program. Run as Java application. Okay, as we see, it finds the digraph, and host 2 have 2 outbound links. Host 1 have 1 outbound links. So you can see 1 and 2 are strongly connected. Host 3 is not. And as the result shows, 1 and 2 strongly connected, 3 is not. And this is the pre-order, post-order, reversal order. So let's check out on the website. So this is, we start. 3 is not strongly connected to any one, so let's check out why, because it only have internal links and it's not working. So page 3 is not strongly connected, but 1 and 2 are strongly connected. This one have a link, outbound link to 2. 2 have back link to 1, so they are strongly connected. Now we get a simple controlled LAN that's randomly generated some LAN. So we can test out the algorithm. I already randomly generated LAN and run through the algorithm multiple times, so have good confidence about the algorithm. But let's run several rounds. Random LAN is just randomly generate some page and outbound links, and create a site. So in this case, it don't have any because it's random. Next time, have 2 nodes, and it find out 7, 1.27. 7 don't give backlink, so they are not strongly connected to each other, but they are strongly connected to themselves. Let's run. This time we get a larger intranet, 13 nodes. And we get a diagram 1 link outbound link 4 and 8, so they're not strongly connected. As you see, it's not strongly connected. Let's run again. This time I get a larger one. So 5 outbound to 6, 7. Well, so they're not strongly connected. Let's get some case of strongly connected. 48. Okay, this is more complex. Yeah, there's the 3, has 7 linked to 2. And it shows me there are no strong. Yeah, there is strongly connected components 3, 0, and 3. 0, 0, and 3. So let's check. 3 have outbound to 0, 0. Give give link back to 3, so they are strongly connected. Okay, fair enough. And this time we have 4, 3, 6 strongly connected, and 8 or so. Okay, there's a lot. And if we read through